Okay, in this video, we'll be talking about section 10.6, which deals with theoretical probability. In 10.5, you talked about experimental probability, which is, for instance, let's say you flip a coin and 3 times you get heads and 1 time you get tails. Well, based on that experiment, you have a probability or an experimental probability of getting heads 3 out of 4 times and an experimental probability of getting tails 1 out of 4 times. Again, that probability is based on the data you collected. But with theoretical probability, it is essentially like it says, it's what your probability is based on theory. Okay, so the learning target will be I can determine the theoretical probability of an event and also convert between probabilities and odds. So we'll talk about the odds here a little bit later on. For starters, if you look at the bottom here, it says theoretical probability. And what that is a fraction or really a ratio of the number of ways an event can occur divided by the total number of equally likely outcomes. And by that we mean, for instance, if you roll a number cube or a dice or a die, there are 6 equally likely outcomes, 1, 2, 3, 4, 5, or 6. If you pull a random card from a deck of cards, there are 52 equally likely outcomes. If you flip a coin, there are 2 equally likely outcomes. Okay? So we're always concerned with theoretical probability about how many outcomes there actually are. All right, taking a look at some examples here. Number 1 says an experiment consists of rolling a number cube, which again is just another name for a die or dice. Now there's a typo. It should read, find the theoretical probability of each outcome. So for starters, for letter A, they're asking us to calculate the probability of rolling a 5. Well, for starters, this is how we would write that, a capital P. We want to know the probability of rolling a 5, so that's how we'd go ahead and show that in terms of math. So going back to the ratio for a theoretical probability, again, it's the number of ways an event can occur divided by the total number of equally likely outcomes. Well, if we're looking to roll a 5, there's one way that can occur, and there are 6 equally likely outcomes. Okay, so we write that first as a fraction, 1 over 6. Your teacher may or may not ask you to reduce the fractions. Obviously, in this case, you can't. But once we have it as a fraction, we then type that into our calculator and convert it to a decimal, which we then go ahead and change to a percent. Now, your teacher may ask you to do it to the nearest whole percent or possibly to the nearest tenth. I'll go ahead and show it to the nearest tenth on my examples here. So that would be your answer. The probability of rolling a 5 essentially is a 1 out of 6 chance, and in terms of percentages, that's a 16.7% chance of having that occur. If we want to know the probability of rolling an odd number, again, this is how we could show this. So the probability of rolling an odd number, and in that case, we could have a 1, a 3, or a 5 being rolled, each of those being odd numbers. And again, there are 6 equally likely outcomes. Okay. Again, your teacher may or may not ask you to reduce that fraction, but then we're going to change that to a decimal by using the calculator, although you should be able to do that in your head. And then finally, we'll go ahead and change that to a percent. So you have a 50% chance of actually rolling an odd anytime you roll a number cube. And then finally, the last example here, we want to know the probability of rolling a number less than 3. So we'd show it this way. And thinking about this, the only way you can roll a number less than 3 is to get a 1 or a 2. So there's 2 ways that event can occur, and there are 6 equally likely outcomes. And again, we may or may not have to reduce it. When we punch that in the calculator, we get 0.3 repeating. Don't really need the second 3 there. And writing that as a percent to the nearest tenth would give us 33.3% chance. Okay. Moving on, talking about another term related to probability, something called a complement. And a complement of an event are all the outcomes not included in the event. Mathematically, the way we show that is we'd say, okay, we know there's a 100% chance of an event occurring, and it's the probability of the event happening plus the probability of the event not happening. In other words, it either happens or it doesn't, and together that adds up to 1 or 100% in terms of a percentage. Okay. So let's go ahead and take a look at this next example here. It says a box contains only red, black, and white blocks. The probability of choosing a red block is 1/4, and the probability of choosing a black block is 1/2. What is the probability of choosing a white block? So I'm going to give you a little bit of time to think about this. Why don't you hit pause? When we come back, I'll have some of the work shown, and we'll go ahead and go through the rest of the problem. Okay, hopefully you had a little chance to think about this problem. I've started out here by indicating some of the given information. We have the different probabilities listed there. And in blue here, I basically set up an equation showing that all these events added together, which is the probability of getting a red or a black right here, that's the probability of not getting the white, like they're asking us for, plus the probability of white, which is the event we're looking for to occur. Those two together should add up to 1 or 100%, okay? Because they're complements. You either get a white or you don't get a white. There's nothing else that can occur. So again, that adds up to 100%. Now, in terms of calculating this, the probability of getting a red, we said is 1/4. Probability of getting a black is 1/2. We don't know the probability of getting a white, but again, it has to add up to 1. So just doing a little bit of quick algebra here, we're going to get like terms, and we're going to figure out what that x is. So we get 3/4 plus x equals 1. I'll have to subtract the 3/4 from both sides. Kind of getting tight on space, so I'm going to write it over here. When I do the algebra there, I end up getting x is equal to 1/4, and that represents the probability of getting a white. I'm going to roll it over here. I'm sorry, write it over here on the left-hand side. So the probability of getting a white block ended up being 1/4. And if you did change that to a percent, obviously, that would be 25%. But again, we figured out that the probability of not getting a white was 3/4. That combined with the probability of getting a white should add up to 1%. I'm sorry, add up to the number 1. Okay? So that's what complements are all about. It's together, either the event happens or it doesn't, and they add up to 1. All right, we're going to transition now from probability into odds. They're related, but they are two different things. There's two ways of expressing odds. When we talk about the odds being in favor, it's, again, another ratio. It's the number of ways an event can happen, which sometimes we call good or simply can, and it's divided by the number of ways an event cannot happen, or sometimes we'll simply call that bad. And another way to think about it here is in terms of that ratio written like this. It's the good over the bad, or the good to the bad. Now, the odds against is the exact same thing, except it's written as a reciprocal. The odds against are the number of ways an event cannot happen, or bad, divided by the number of ways an event can happen, or good. And again, we can kind of shorten that to this little ratio. But once again, if you notice, they're simply reciprocals. Whatever was on top in the numerator position got moved to the denominator, and the denominator got moved to the numerator position to create the odds against. So the same thing, just kind of flipped over. All right. Now, with that in mind, let's go ahead and take a look at number 3. It says the probability of rolling a number 2 on a number cube is 1 to 6. Or, I'm sorry, 1 out of 6. Okay? What are the odds of rolling a 2? All right. Well, if you think about this, when we're talking about odds, it's always, let's see here. Let me go ahead and hit pause. I'm going to go ahead and put some information up here first while you think about the problem. Okay, back to this example. I was going to write some things down ahead of time, but I figured it might be better to simply work through it with you here and label as I go. One of the easiest things to do when you're doing this is simply to label it. Okay, when we're talking about probability, we know that bottom number is always representing the total number of outcomes. Okay, the top number is representing the good event, or the event that we're kind of talking about. So in this case, when we say the probability of rolling a 2 on a number cube is 1 out of 6, we're saying there's one way that can happen out of 6 total outcomes. Okay. Well, if there's one way of that happening, that means there's 5 ways of it not happening. Okay, which is sometimes called bad. So we have one good way and 5 bad ways. Now, keeping that in mind and going back and look at what the problem's asking us for, it says, what are the odds of rolling a 2? So when they ask us for the odds, they're essentially asking us the odds in favor. So looking at the ratio, it's the number of ways an event can happen, which in this case is 1, divided by the number of ways an event cannot happen. In other words, the bad events, which is 5. So that would be your final answer, although a lot of times it's going to be written like this. In either case, the odds would be 1 to 5. Little trick here, keeping in mind, the sum of these two numbers, okay, those two are always going to add up to the denominator here when you're talking about probability. In other words, they're always going to add up to the total number of events. So this one is talking about how many good outcomes there are. That 5 is talking about how many bad outcomes there are, or how many ways can it happen compared to how many ways it can fail to happen. But in any case, that would be your final answer if they're asking you for the odds of rolling a 2. Okay. Again, number 4, I'm going to give you a little bit of time to think on this on your own. So I'm going to go ahead and pause, and why don't you do the same? And when we come back, we'll go ahead and discuss this solution. Okay, hopefully you had a little bit of time to think about that. I think in attacking this problem, what I'm going to do is go ahead and label things here. If they're saying the odds in favor of winning a contest are 1 to 9, that means there's 1 good way of that occurring and 9 bad ways. In other words, 1 way it can happen and 9 ways it can fail to happen. So keep in mind, that's a total of 10 outcomes. So on letter A, when it asks what is the probability of winning the contest, well, that's essentially saying this. Correct form there. The probability of winning a contest, well, again, remember the probability, it's how many ways can it happen, or how many good events are there, divided by the total number. So in this case, it would be a 1 out of 10 chance, which translated into a percent would be equal to 10%. So you have about a 10% chance of winning that contest. Now, it says, what is the probability of not winning the contest? So it would express it like this. The probability of not winning, well, if there's 1 way that you can win, that means there's 9 ways that you can fail to win. And again, that's out of 10 equally likely outcomes. And translating that to a percent would give you 90%. Now, if you take a look right here, these events would be considered complementary events because there aren't any other outcomes. You either win the contest or you don't win the contest. That should add up to 100% because there's nothing else that can happen. Again, those are complementary events. And then one last example before I ask you to go ahead and try some on your own. It says the odds against a spinner landing on red are 2 to 3. What's the probability of a spinner landing on red? So again, I'm going to hit pause and get a chance to think. Okay, hopefully you had a chance to think about this. Now on this problem, the key words right here, odds against. So if they're giving you this ratio of 2 to 3, that 2 is representing the bad outcomes. 3 is representing the good outcomes. Okay, so when they're talking about the probability of a spinner landing on red, let's go ahead and show that properly. That means there are 3 good outcomes, or 3 ways that can happen, out of a total of 5 outcomes. We have the 2 bad, the 3 good for a total of 5. So we have a 3 out of 5 chance of that happening, which again, translated into a percent, or converted into a percent, would give you 60%. Okay? So there are some examples for you. What I'm going to do now is I'm going to go change to the next flip chart. There is a lesson quiz for you to try on your own. Why don't you hit pause right now, try them on your own. When you come back, I'll have all the solutions there along with all the work, and you can check it on your own, and hopefully the work that's being shown is good enough for you to understand each of the problems. So good luck, give it a shot. Okay, I'm going to go quickly to get through these last examples. Number 1, the key here is that there's only 1 B out of 7 letters total, so we have a 1 out of 7 chance in terms of the probability. And I forgot to change that to percent, but no big deal, you should know how to do that. For number 2, pretty self-explanatory. The factors would be 1, 2, and 5, so we have a 3 out of 6 chance. 3 should be okay on. I believe 4 should be okay also. Just keep in mind, there's 3 good, meaning 10 out of 10 total. That means there would be 7 bad. Now, number 5, I just want to clarify here, make sure you're okay. If it says odds against a spinner landing on blue, that means there's 7 ways of the bad event occurring, if you want to call it that, and 6 ways of good. In other words, 5 ways of good. In other words, there's 5 blues, which I showed right here. The problem said there's also 5 red sections, meaning there's 2 unknown because we know we have 12 total because of the 7 to 5 ratio right there. Well, they want to know the probability of getting a red. Again, there's 5 ways of getting a red out of 12 ways total, and that's how we would calculate the probability. 5 out of 12, which translates to 41.7%. So, I hope this video was helpful. Good luck with this section.